In our last episode, we talked about bias before an algorithm is even built, how it can sneak in during the earliest stages when we are deciding what problems to solve and whose stories to prioritize. Today, we are moving one step forward to bias during the development of algorithms. Machine learning happens through experience, just like humans, but instead of learning from life, AI learns from data, from examples we feed it. And that dataset, that training material, can become one of the biggest sources of bias. To make things more concrete, let's stay within the world of healthcare. It's a perfect example because the stakes are high. People's lives and well-being depends on getting it right. But remember, these patterns of bias appear in many other domains too. In education, law, finance, hiring, and beyond. So let's imagine you're building an AI to help doctors make better decisions. Maybe to spot diseases earlier or predict who needs treatment. Sounds amazing, right? But what if from the very beginning, the data you give that AI is quietly teaching it to favor some people and fail others? That's what we mean by bias during development. When an AI learns from examples that don't represent everyone fairly. Let's unpack how that happens, step by step. First, imbalanced sample sizes. Imagine building a medical AI using thousands of scans from white patients, but only a handful from black patients. The AI will get very good at recognizing what illness looks like in white patients and not so much in others. It's like training a facial recognition app mostly with light-skinned faces. When it sees a dark-skinned face, it just gets confused. The result? A tool that works beautifully for some, but not for others. Second, missing patient data, but not randomly. Some groups simply have more gaps in their medical records. Maybe poorer patients cannot afford certain lab tests, or maybe certain hospitals don't record every detail. The problem is that the AI doesn't just see missing data. It sees a distorted picture. It learns patterns that don't tell the whole story. It's like trying to grade students when half of them never took the exam. Your results won't be fair or accurate. Third, data that's hard to capture. Not everything that affects health fits neatly into a database. Think about stress, loneliness, housing conditions, or access to healthy food. These invisible forces shape our health just as much as biology does. But AI often cannot see them. It's like trying to predict how well a car will perform without knowing how often it's maintained. Without those hidden details, predictions will always fall short, especially for people whose lives are shaped by those missing factors. Fourth, bias in labels and classifications. AI learns from examples that humans provide. But humans make mistakes. Doctors might misdiagnose patients, or their judgments might be colored by unconscious bias. If those labels are used to train AI, the machine simply absorbs and repeats our errors, only faster and at scale. Finally, incorporating irrelevant variables such as race and ethnicity into clinical algorithms remains problematic. For instance, certain medical formulas continue to include race as an adjustment factor, as though it reflected a biological reality rather than a social construct. When this occurs, the AI system risks internalizing and reproducing biases by embedding irrelevant and misleading data into its decision-making processes. So when we talk about bias in AI, it's not that machines are bad. It's that they learn from a world that already contains inequality. And if we are not careful, they will copy and even magnify it. I am Ehsan Erzurumchilar, a researcher of technology, and I invite you to join me in exploring how technology transforms our sense of what it means to be human.